Hello, everyone. My name is Bart Gajderowicz. I am a postdoctoral fellow at the Center for Social Services Engineering at the University of Toronto. And today I'll be presenting my work that I did with my colleagues Daniela Rosu and Mark Fox on extracting impact model narratives from social services text. This project was done in collaboration with our data partner at Help Seeker Technologies as part of the Compass project. What I'll cover today is give you an introduction to our motivation, give you an example of named entity recognition, and outline some of the challenges that we face in this work. And then I'll give you an example of what we mean by a narrative. And then I'll go into some details of the methods that we've developed, show you some results, and finish up with future work. So the motivation for this work is that 65,000 social service providers across Canada offer services to nearly 5 million Canadians that live in poverty, and the thousands of new immigrants and refugees that are welcomed into Canada every year. The Canadian federal government coordinates with private and public agencies to fund the vast majority of social programs that are offered to clients today. And they use a variety of tools and indicators to analyze how well those services are reaching the populations in need. Social purpose organizations, or SPOs, are the actual organizations that deliver the services to the different populations. And the challenges that we face is that navigating this network of SPOs and funders is difficult when you're trying to align a particular service with a particular client and their needs. Secondly, determining the efficacy of the services assigned to the different clients is actually quite difficult. Just to give you a refresher on named entity recognition, this is a task within the natural language processing literature that assigns entities to particular terms in text. Here's an example of a social service description with each of the entities highlighted. So here, the Legion is assigned to a type organization. Representation and assistance is assigned a service type. Veterans, Canadians, Armed Forces, RCMP, and families are the different clients. No cost is describing the requirement, and Legion members is describing the eligibility for the clients. There are a number of challenges in applying NER to the SPO domain. The first one is the lack of language models for our particular domain. There are many pre-trained models that do identify entities such as a person's name, dates, locations, numbers, etc. But there's no such model for specific for the SPO domain and that identifies different services, different client characteristics, their needs, and so on. There are vague definitions of what actually defines each of these entities. For example, there's no definition for what defines a program, what defines a service, what is a need, or a client characteristic. There's also a lack of standard labels across the different SPOs assigned to specific instances of either a program or a service or a client. So for example, there's different definitions of what defines a homeless person, and there are different definitions for what defines a mental health program. Next, there's a lack of structured data about the services. So most of the information is actually provided as unstructured text, as descriptions of the services. Often this information is provided as promotional material. Often it highlights the populations that they focus on without listing the actual requirements. And finally, there is a lack of information about how the different services are put together so that you can have a cohesive service plan for a particular client. So how to sequence each services to reach a successful outcome for a client. These are the entities that we focus on within our work. These entities are taken from a common impact data standard, which is an ontology that defines the social services and the semantics that define the relationship between the different terms. So here we have a program name, which is self-explanatory. We have a need satisfier, which is the actual resource that's used to deliver the service to the clients. Different ways that we define client characteristics, the client's needs, the desired states or the outcome that they want, and the general description of the services, the clients, and the need satisfiers. And finally, what is the requirement criteria that a client must meet before they can use the service. Here's an example of what we mean by a narrative, and I'll use the terms in the top right corner to define this narrative. So imagine we have new immigrants that want financial independence. Each immigrant has varying levels of language skills and professional skills, and a particular client must navigate these different services to meet their needs. So we begin with a client who's a new immigrant. Their need is finance. Because they're an immigrant, they're eligible for a language assessment program within the YMCA, the service itself being the language assessment, and it's delivered through two need satisfiers. It has student registration and the actual evaluation of their language skills. Next, the clients can be passed on to another YMC program called language classes, and this is where the actual classes are administered. So here, the students are enrolled, but they're enrolled in specific classes for their particular needs. In this case, meaning their particular language assessment level and the outcome that they're looking for. So one client could have no language skills and no professional skills, so they can be assigned to the level 1 class. And the outcome of this class would be that they are able to interact with financial assistance agencies. Next, we have clients who have conversational skills, but they don't have any professional skills. So they'll be assigned to the level 2 classes, and they might be ready to apply for temporary jobs. And finally, we have clients who have conversational language skills, but they also have professional skills. And those clients would be assigned to classes that are able to increase their professional vocabulary so they can find a long-term job. Okay, so this is what we mean by a narrative of a client that would follow a particular path to reach their goals. Now, to be able to build such a narrative, we have defined our Ner architecture, which I'll highlight here, and I'll go into the details in further slides. So we begin with a set of documents that describe the different services. We perform pre-processing to identify the POS tags, the dependency trees, and the co-reference resolutions. And then we apply a set of rules to combine this information into something that we can start extracting entities from. Now, the entities themselves, again, come from the Common Impact Data Standard, which provides not just different entities, but also the semantic relationships between those entities. So once the entities have been identified, we can then start running them through a semantic roles parser, which gives us the semantic roles that you see on the left, bottom left of the slide. And these kinds of relationships are what we use to actually build the narrative that you saw in the previous slide. Now for some definitions. So we begin with D, which are the documents that we use as input. And these are, again, the descriptions of the different services that capture the kinds of information that we're looking for. Next, E are the actual entities that we want to extract from the text D. For example, a program might be St. Mary's or the center. Client characteristics might be youth, family, or hungry kids. Next, we have the triples that we extract. So these are subject, predicate, object triples, such as we offer health services to local communities, and so on. And within a triple, we have 3 different slots, which are SPO, which represent the subject, the predicate, or the object. Next, we have T sub D, which is a subset of the triples that are extracted from a particular document D. Now I'll show you how this is applied with an example. So here's an example that we introduced before, when we're highlighting the different entities. The Legion also provides representation and assistance to veterans, including currently serving Canadian Armed Forces and RCMP, and so on. So a sentence like this, the pre-processing generates a dependency tree that you see here, as well as different POS tags and co-reference resolutions. So this kind of information is then fed into the model. So first, a set of rules are used to generate T-triples. So we start off with the different terms in the sentence, their POS tags. We then use their dependencies between those terms. For example, here, Legion is a subject of provides, representation is the object of provides. And we have a set of rules to assign different slots in a particular triple to these terms. Now, this is a simple example. There are other rules that deal with more complex examples in sentences that we found. Next are the T-chains. The T-chains essentially combine 2 or more T triples together. So for example, we start with one T triple and we extract another. Here we have the representation serving forces. We built up our triple, and then the new T-chain rule combines these triples together to generate this kind of quintuple. And this quintuple structure can then be used by another rule to extract new information. For example, we might have a rule that connects Legion to serving forces. And what this tells us is the Legion actually provides the services described previously to Canadian Armed Forces, being the client here. Here's an example of an implementation of such a rule. So this is a rule that extracts triples, and we use Prologue for our implementation, and so we will use the Prologue syntax here. And essentially, we start off with the head, which is the consequence of the rule, and we finish with the body, which is the condition. So for example, if we know that the subject is for a particular predicate, and O here being the object for the same predicate, and if that predicate does not have an oblique nominal, that means that SPO is a triple. Another example here with a very similar format, except at the end here, it actually looks at the actual values. So not just the dependencies, but also the values. So if all of these dependencies are true, and the predicate is either the term 2 or 4, then SPO is also a triple. Next is an example of a T-chain. This is a very simple rule. It takes two T triples, connects them through the first triple's object and the second triple's subject. Make sure that these are not the same predicates and objects. And then if all these statements are true, then we say that this is a T-chain, which makes up our quintuple. And then such a quintuple can then be used by other rules to extract additional information, as in the previous example. Next, I'll give you an example of an entity extraction rule. We'll use, again, Prologue syntax to do this. So this particular rule identifies an object in a triple as a neat satisfier. You can see here that we begin with identifying a particular triple, and then we check the predicate's POS tag. We can look for specific values in the POS tags, as we do here for the subject. We can use for specific values of the different terms, as we see here for the subject. We can also exclude certain POS tags from the object. And finally, we can look at not just the terms, but also their modifiers. So here we look at the modifier of the object, and then we look at the modifier's POS tag. And if it's one of these, then we can say that this triple has in fact a neat satisfier, and it's the object that is the neat satisfier. Next, we go on to scoring the rules. We use the Matthews correlation coefficient, or MCC score, to rank each of the results of the rules. We use that in equation 1 to classify each extracted term as either being correct or incorrect. So if the MCC score is above 0, then we say that it is correct. If it's 0 or less, then it's false. We then take equation 2 here and create a score or a weight WI for that particular result to tell us whether it was correct or not. And finally, for each of those rules, we aggregate them together under one score, W sub E, for how well the model extracts that particular entity. And so by aggregating these scores, we can calculate how well the model performs on a particular entity. And I'll show you how that's done in a second. Here's a quick summary of the data that we used. So we used just over 16,000 descriptions of service providers. We were able to extract just over 7,000 triples. And from these triples, we were able to identify just over 48,000 entities. Here's an example of how the rules are applied to extracting neat satisfiers in that data set. So here we have, you see that neat satisfiers have actually the best coverage with 13 rules. Not every entity has this many rules, but this is a good example. The rule itself it identifies its number in the list of rules, here being number 44, and also identifies which slot was used. So what this rule is saying is that the object within the triple is the term that was actually the need satisfier. Now, for each rule that we analyzed, we calculated how many true negatives, false positives, false negatives, true positives it had. Then we calculated the precision, recall, F-score, accuracy, and the MCC score. As you can see that each rule actually has different accuracy, different recall, and so on. And so we had to find a way to find the best rules and the best terms to be able to aggregate this score and say whether the model was actually good at identifying need satisfiers based on how well each rule performed. And so this is where the first equation came in. And we said that if MCC score is greater than 0, then the rule classifies it correctly, 0 otherwise. And so based on this information, we recalculated the true negatives, false positives, and so on. And these are the values that the model produced. And you can see that based on the aggregate scores, the precision is actually quite high, the recall is high, the F-score is high, and the accuracy is relatively high. You can see that it's actually higher than the majority of in each rules individually, but its coverage is also higher. And finally, to evaluate how well our score captured the correctness of the model, we performed ROC analysis to see how well the score coordinates with correct values. So in this case, the need satisfier has a value of 0.73, which is acceptable. And I'll show you this in the next slide. So just to summarize, the way that we evaluated each entity's extraction by the model, we looked at the accuracy. Here, N represents the number of entities that were extracted for this test. DOC is the number of service descriptions for the documents. And so you can see that for the need satisfier, the model has a 59% accuracy. And to evaluate the scoring method, we performed the ROC analysis, and we see that the area is above 0.7 at 0.73. And so we can determine that this is acceptable for the need satisfier entity. Here are the accuracy scores for each of the entities that we were concerned about. And you can see that these 5 actually performed better than guessing, some having higher scores than others, but these we consider acceptable for the first variation. The ROC analysis for each of the different entities, we can see that the highlighted entities have a acceptable score of greater than 0.7. These being client descriptions, need satisfiers, need satisfier descriptions, and program names. Just to summarize the results, not all entities have the same number of rules, and not all entities are covered equally. The results were evaluated manually, and each entity was selected at random. And so there's not equal coverage across all entities, but more analysis will be done in the next iteration of this work. Rules that identify significantly more true values but are not good at excluding false values can produce negative MCC scores. So this is actually an artifact of the Matthews correlation coefficient. And what we observed was that even though we had a low MCC score, we still had a high F score and even a high accuracy. This is especially observed for the client characteristics and the required criteria. And so we see that the MCC score is actually sensitive to large discrepancies between true and false values. This is something that will be looked at. So in future work, we want to extend the model with additional features and training data. We want to add additional rules based on that data. For example, we want to add the negated phrases that tell us that a program does not provide a particular service. We want to introduce a larger corpus with correct annotations that allow us to train statistical methods and supervise machine learning models. And finally, we want to incorporate available data about associated services and client outcomes so that we can actually identify which paths within the different narratives that are available to a client are going to be more successful for the client in the subsequent steps. So that is the end of the presentation, and thank you for your attention, and I welcome any questions at the end of the session. Thank you.